Hello friends, I welcome you in lecture number 2 on basic statistics. In previous lecture we have discussed certain things about frequency distributions and we have understood how we can arrange our data in terms of ungrouped and group frequency distributions. In this lecture we are going to discuss about measures of central tendency or measures of location or averages. Now, in all these concepts which we are going to discuss, we require some knowledge about two terms. One term is population and another term is sample. So, before starting for this topic, measures of central tendency, we just take the idea about those two terms, population and sample. So, for example, suppose we are interested in the study of result of students of some college. Say suppose we are interested in the result of students of GEC Modasa. So our focus is or our project under study is result of students of Government Engineering College Modasa. So one thing we can do is we can find out result of each and every student of GEC Modasa for particular year, and then we can study in that way. But sometimes due to lack of time we are not able to do this study for each individual student. So what another thing we can do is we can consider a small group of students from this college. Suppose we consider 100 students of some different branches, and we study about the result of this small group instead of this large group. So this large group, which contains all the possible elements under study, is known as population, and the subset of this population is known as sample. So instead of studying about population, what we can do is we can draw some sample from this population and we can study about result of students in this sample, and from this study we can draw the conclusion about this result of this whole population. So this type of study is known as statistical inference. We draw a sample and we infer about the result of students. So this type of study is known as study is known as statistical inference, which we are going to discuss after completing this topic, basic statistics. So now onwards we must be clear about population and sample. Population contains all the elements under study. Sample is a subset of population. So sample is a small group of members or elements. Population contains all the members under study or all the elements under study. So here I have written definition of population and sample. A population is the set of all elements of interest in a particular study, and a sample is any subset of the population. And these are the different examples of population and sample. First example is advertisements for IT jobs in Canada, and this sample is from this population. The top 50 search results for advertisements for IT jobs in Canada on December 12, 2021. So this is example of population. Here it contains all the advertisements for IT jobs in Canada, and here we have taken top 50 advertisements for IT jobs in Canada on particular day. Second example is undergraduate students of GTU. So this is the example of population, and this sample is collected from this population, 100 undergraduate students of GTU who volunteer for your psychology research study. Third example of population is all countries of the world. and this sample is taken from this population. Countries with published data available on birth rates and GDP since 2005. So this set is a subset of this population. So I think it is easy to understand what is meaning of population and sample. So with this in mind, we start today's topic, that is known as measures of central tendency. So a measure of central tendency is a single value, or it is a single number that attempts to describe a set of data by identifying the central position within that set of data. Measures of central tendency give us an idea about the concentration of the values in the central part of the distribution. Another name for measures of central tendency is average. So an average is a value of the variable which is representative of the entire distribution. For example, if we consider average result of students of some college, then that number which will be the average result is representative of the students of entire college. There are three main measures of central tendency which we are going to study in our course. Mainly we are going to study these three measures of central tendency, namely mean, median and mode. So we will discuss all these three measures one by one, how to compute these three measures or these three averages. We will discuss first that how to obtain these measures of central tendency for ungrouped data or raw data. Then we will discuss how to compute these measures for group data or grouped frequency distributions. So first we define these three measures for ungrouped or raw data. So first one is mean. Another name for mean is arithmetic mean. Now when we are defining mean, then we are familiar with the definition of mean or average. So average means, suppose we have n observations, say x1, x2 up to xn, then we are familiar with the definition of mean. We have to take sum of all these observations, that is x1 plus x2 and so on xn, and we have to divide it by the total number of observations, which is n. So this is the definition of mean. Mean of given observations equal to sum of all the observations divided by number of observations. Now suppose we have these observations are coming from a sample, then mean is known as sample mean and it is denoted by this notation x bar. And if these observations are coming from a population, then notation for mean of population is mu. So remember these notations. X bar is the notation for sample mean, and for population mean notation is mu. This is Greek letter mu. Definition is same. We have to add all the possible values given and we have to divide by number of observations. Mean is the most important measure of central tendency. If the data are from a sample, the mean is denoted by x bar, and if data are from a population, the mean is denoted by this Greek letter mu. First we have written the definition for sample mean. If n observations in a sample are denoted by say x1, x2, xn, the sample mean is given by x bar equal to x1 plus x2 and so on up to xn. That is, we are taking sum of all these observations divided by total number of observations. We can write in sigma notation also, sigma xi I equal to 1 to n divided by n. Or if we don't want to use this suffix I, we can simply represent in this way also. This is also valid, sigma x divided by n. It is not necessary that we have to specify this suffix I equal to 1 to n. This means sum of all the x values divided by n. Definition of population mean is same. The only change is in the notation. Instead of x bar we will write mu. So So here we have mu for the notation of population mean. The formula for mean of population remains the same, but we use different notation to indicate that we are working with the entire population. The number of observations in a population is denoted by capital N. The number of observations in a sample we have denoted by small n. And the symbol for population mean is mu. So this is the definition for population mean. Mu equal to sum of all observations divided by capital N. So if we have sample mean, we denote it by x bar. Population mean will be denoted by mu. Number of observations in a sample will be denoted by small n. Number of observations in a population will be denoted by capital N. So try to remember these different things or different notations for sample and population, which we are going to use in the upcoming chapter on statistical inference. Here we have taken simple example. A random sample of 10 boys had the following intelligence quotients 70, 120, 110 and so on. So there are 10 intelligence quotient values and we are asked to find out mean intelligence quotient. So here we have sample of 10 boys. So value of n is 10 and the mean is given by sum of all these values divided by 10. Here we have written mean intelligence quotient is given by x bar equal to, here we have in the numerator sum of all these values divided by 10, and if we sum these values in the numerator we obtain 972 divided by 10, that is 97.2. So this is the sample mean. So it is very easy to calculate sample mean. Now second measure of central tendency is median, and that we are going to define for sample, so that is known as sample median. Median is another measure of central tendency for a variable. Median is the value in the middle when the data are arranged in ascending order, that is from smallest to largest value, or in increasing order. To find out median of a data, first we have to arrange all the observations in this order, either ascending order or we can say that from smallest to largest. If we wish, we can arrange in descending order, that is from largest to smallest also. With an odd number of observations, the median is the middle value. Suppose number of observations are odd, then middle value will be the value of median. Here we have taken one example to explain this. In order to control costs, a company collects data on the weekly number of meals. This is our variable under consideration, weekly number of meals. Claimed and expense accounts. The number for 5 weeks are 15, 14, 2, 27, 13, and we are asked to find the median for this data. So first we arrange this data in ascending order. So we start from smallest to largest value. Smallest value is 2, then we have 13, then 14, then 15 and then 27. So here number of observations are 1, 2, 3, 4 and 5. So we have odd number of observations. So middle value will be the value of median. So we can see this is the median because it is middle value. So median divides the data into two equal parts. Here we can see this is one part, this is another part. So median is the middle value of the data. Half of the observations are on this side, half of the observations are on this side. So here we can directly write that median for this data is 14. Now if number of observations are even, then median is the average of the two middle values. So that we understand with the help of this example. An engineering group receives email requests for technical information from sales and service. The daily numbers of emails for 6 days are 11, 9, 17, 19, 4 and 15. Find the median. So here number of observations are 1, 2, 3, 4, 5 and 6. So number of observations are even. To find out median, first we arrange these observations in ascending order, that is starting from smallest to largest. So ascending order of given observations is smallest value is 4, then 9, then 11. So 4, 9, 11, then 15, 17, 19. 15, 17, 19. Now here we have written that if we have even number of observation, median is the average of the two middle values. So we find out two middle values here. We can see these two are two middle values. So median equal to average of these two middle values. Median is 11 plus 15 divided by 2, that is 5 plus 1 6, and here we have 26 divided by 2. So median is 13. So in this way it is easy to compute another measure of central tendency, which is median. We have to remember that if number of observations are odd, middle value is the median. If number of observations are even, then average of two middle values is even. Now sometimes what happens, suppose number of observations are very large, say n equal to 200, then it is not comfortable to decide what is the middle value by observing the given data. So in that case we have a formula for the median. Suppose we have n number of observations, and if n is odd, then median will be equal to observation at n plus 1 by 2th position, or n plus 1 by 2th observation. For example, in this case our n was 5. So we can find out n plus 1 divided by 2, that is 6 by 2. So median is at the number 3, or position of median is at third position, and we can see here third position is our median. So we can remember this formula that if n is odd, median lies at the n plus 1 by 2th observation, or at the position of n plus 1 by 2th. Now suppose n is even, then here we have written that if n is odd, observation in position n plus 1 by 2 is median. Now if n is even, then average of two observations in position n by 2 and n by 2 plus 1. So that we can understand for this particular problem. We have to find out these two positions, n by 2 and n by 2 plus 1. Here n was 6. So n by 2 means 3, and n by 2 plus 1 means 3 plus 1, that is 4. So we have to take average of observations at these two positions, third and fourth position. And here we can see we have taken average of this third and fourth observation, 11 plus 15 divided by 2. So if data is very large, we can remember this formula for sample median. Sample median equal to observation in position n plus 1 by 2 if n is odd. Sample median equal to average of two observations in position n by 2 and n by 2 plus 1 if n is even. Third measure is mode. So it is very easy to find out mode. Mode of a data set is the value that occurs most frequently, or the observation which is repeated most frequently. So here we have considered the data set showing the retirement age of 11 people in whole years. So here we are having these observations. So we find out that observation which is repeating most frequently. So from this we can see that this 54 repeats 3 times, 56 is not repeated, 57 repeats 2 times, 55 repeats single time, and 60 is repeating 2 times. So mode of this data is 54. So mode is the value that occurs most frequently. So in this way we can define these three measures of central tendency: mean, median and mode for ungrouped or raw data. So in this lecture we have discussed how to compute mean, median and mode for ungrouped or raw data. In the upcoming lecture we will discuss how to find out these measures of central tendency for grouped data or for continuous frequency distributions. So this is all about this lecture. I hope you like it. Thank you.